So today we'll derive the formula for the hyperbolic cosine and the hyperbolic sine by nothing but just its definition on the hyperbola. Okay, so first of all let's look at the circle. So we have the definition of y squared equals 1 minus x squared, and then we have a circle here, and the sine is the height and the cosine is the x coordinate, and we input this angle of alpha here. But what you might also know as alpha is just the arc from this part. This here is also alpha. But since going one full rotation gives us 2 pi, and the area encoded inside of this sector is linear to the perimeter, we could also say that alpha equals the inside area, and since area is pi, times 2. Okay, so the hyperbola is pretty similar. We still have y squared, but we got y squared minus 1 on this side. So the red part gives us the curve of the hyperbola, and as you see it approximates the diagonals. If we go to infinity, it has like 2 branches here, and in the middle it's not defined. We define the hyperbolic sine, which is also called sinh, by this area here, by alpha, which is an angle, but we don't know how to describe this angle because turning it like this way doesn't make any sense. So this is a definition. We define it as 2 times the area, and the area that is encoded in this sector, and here we have encoded in this part, right? Okay, but for this video we will forget that these are called sinh and cosh, but we will introduce 2 other functions, which is called cosh, and it's e to the x plus e to the negative x all over 2, and sinh, which is the equivalent of e to the x minus e to the negative x over 2. And we get therefore the equation sinh squared plus 1 equals cosh squared. And so we are totally not done because, well, this satisfies this equation, right? We put sinh here and we put cosh here and everything works out. But this is not our result because we need the relationship to the area. For example, if I defined 2 constant functions, 0 and 1, this would also satisfy this definition right here of the hyperbola. But that's not enough, right? So in order to go about this, we want somehow the area. First of all, we want the area independence of the x coordinate, and then we put this into the hyperbola definition, and then we hopefully get out a nice formula. So now we want to figure out this area. So we first of all take that this is a triangle, and then we have all of this area, so we have triangle, but then we still have this much to this part too much, which we will call I. So let's see, our triangle will just be equal to the x coordinate times the y coordinate times 1/2. But the integral under the curve will be equal to the integral of 1 to x of just plug in this function t squared minus 1 dt. And that's actually our area. Okay, so that's our formula. Now we can solve some parts. We know that y will be equal to this. So this is 1 over 2x times the square root of x squared minus 1. And then this integral, well, we can't do anything about this integral just now. But what we can do to solve this is, well, here's an integral, so let's differentiate all of that. So we have that area prime is equal to, so let's first apply the chain rule. So this is x squared minus 1. And then we have to add the other part, which is 1 over x. And then differentiate that, so that's 1 over 2 square root of x squared minus 1. And then we have to redifferentiate on the top. So that's 2x. And then we still have to subtract all of this. And because that's an integral that goes to x, we can just use the fundamental theorem of calculus. So this will be equal to x squared minus 1. By the way, the value is at the bottom is not relevant at all because that becomes a constant in the differentiation that doesn't matter. So let's try getting everybody on the same denominator, which will be equal to 2 over x squared minus 1. Of course, here we have x squared minus 1 because we squared this right now. And for the next part, these two cancel, so we still have 1 over 2x squared minus 1, but this times x squared. This will just become 2 times x squared minus 1 over square root of x squared minus 1. So we get 1x squared, 2x squared, and here we have negative 2x squared, so there are no x squares at the top. And we have negative 1, nothing, and plus 2, so this is 1. So now we integrate this. So now let's integrate both sides. Here is to respect to dx. So we let x equal to cosine hyperbolic of u, which has nothing to do with the hyperbola for now, which is just the exponential function we defined earlier. And we get that the derivative of that, you can calculate this yourself. I'll just give it to you. This is sinh of u, du. So we have that this will be equal to, pull the 1/2 out, integral of, let's see, sinh u on the top, du, and on the bottom we have square root of cos squared minus 1. And there's a u there. But we know that cos squared minus 1 is equal to sinh squared, and take the square root, which is equal to sinh, and this means that this is the integral of nothing, like 1 du, and this will be equal to 1/2 u, and this will be equal to 1/2, and then this is the inverse, which exists because we just look at the top part, 1/2 of cos to the negative 1 power of u. But we of course should not forget about the plus c here and there. And we now have to plug in some values. So let's say plug in 1. So this becomes, all of this becomes 0. This is 1/2 times 1 times, let's see, here is 1 minus 1, which is 0. So all of this is 0 if you plug in a 1. And in this, if we plug in 1, we get also 0, which you can also calculate yourself. I won't do this, so this means that c is equal to 0. So this is our area, but what we actually need is the inverse of the area to plug into the function, to plug it into the function of the hyperbola, of course. So first of all, we need to remember that angle was equal to 2 times area. So this means that we get that the angle of x will be equal to just the inverse of the cos function of x. So therefore we get that x will be equal to the cos of the angle. So that's our first result, and our second result is that y will be equal to put cos into x squared, because that's equal to x, subtract 1, and that's our identity. So this will be equal to sinh of the angle of x. I hope to see you soon and watch my other videos, which are also a lot about hyperbolic cosine. So watch them.